really do whatever you guys want to do. If you have specific questions, excuse me, mechanisms you want to see, terminology, things like that, you just let me know. You can either unmute yourself or you can use the chat feature. I think there's a classmate of yours who can't come to these synchronous times, and she's asked for acid-base review, so I will do that today, just to make sure that I get it done.
Dr. Walters, I have a question.
Sure.
Will we ever have a scenario where we have to take a Newman projection and predict like an elimination reaction or a substitution reaction?
Not from a Newman projection. Wait a minute. I take that back. If you have if your substrate for your E2 elimination is a ring, then you at least have to be able to see the alignment. And I guess the trouble, oh my gosh, I'm tired of these markers. Is that, excuse me, if it's in the class, like when we did these together, I put the leaving group up here, and then we analyzed the axial down, hydrogen that was beta. But if there's also a beta here. So if this group in the front had been a methyl, you have to be able to tell that you have this anti-periplanar geometry back here. Oh, sorry, you can't see the leaving group as well. So when you have a second substituent, like if this was not here, it wouldn't matter which of the hydrogens you picked, because your product would have ended up just as a cyclohexene. And you could have put the double bond anywhere because the thing is going to rotate like a record, and so it wouldn't really matter. But if this is a methyl, then when you go around, you have to count the carbons in the ring. So this would be, let's just say methyl, well, if this is a good leaving group like chlorine, this would be carbon 1, this would be carbon 2, this would be carbon 6. The elimination would be between 1 and 6 because they're anti-periplanar. Oh. So if this is 1 and 6, where the pi bond goes, then you would have to put the methyl group on carbon 2. So it's going to depend on how it's shown. Typically, Newman projections of rings are hard because you have to have 2 Newman projections. And you have to have one coming up this direction and one coming up this direction. So they end up looking like this. And so they're tricky. They are tricky. So my assumption, or the way I would approach it, is be able to have a ring substituted, be able to flip it, which is a skill you need from chapter 4, which is the cyclohexane or cycloalkanes anyway, and then be able to identify the correct hydrogens. And the only reason to do that would be like if you had another leaving group here, but you had a bunch of substituents up here, there's no way the bromine could ever be a leaving group because the 2 carbons that are beta to it don't have a hydrogen. So the rings could be complicated, but the likelihood of if you wouldn't make a diene, a compound with 2 alkene, so there would only be 1 leaving group, I think is the best way. That's a really like roundabout way to answer your question, sorry. But did that help?
That helps. So we are not going to see anything that complex on the final.
Not where you would have to be able to do this in order to get to a product. But if you had, let's say you had this compound. And it did have all that stuff on there. Now the numbers for naming don't really matter. 1, 2, that would still 3, 4, 5, and 6. Your pi bond would still be between 1 and 6. 2 has a methyl, 3 has a methyl, 4 has a bromine, 5 has a methyl. So, I mean, I guess it could be that tricky, but like I said, we didn't talk about doing double eliminations on alkyl halides. We talked about doing double eliminations on alkyl dihalides to make alkynes, but not in the sense of antiperiplanar and making a cyclohexene, a substituted cyclohexene. So yes, you could see something like this, but my advice would be you're only going to have the likelihood, high likelihood is that there's only going to be 1 leaving group. So you just have to make sure that you eliminated the right proton and then made sure that all of the substituents were on the right ring. And then once it's drawn as an alkene, I don't foresee it being drawn, the alkene pi bond in the ring, because then these carbons have different hybridizations, and so it's not going to look exactly like this.
Okay, thank you. That makes so much more sense.
Okay, great. Anything else?
I have a question.
Sure.
So, do you have, I guess, access to the questions? So, I'm sorry. Yeah. Can I be more
Yeah, I do.
I'm sorry. Yeah, the questions. You don't know? Come on.
Yeah.
Sorry.
Okay.
I have the video.
Oh.
Or I'm sorry, the book.
Solutions manual. Yeah.
So there's a few that I was looking at in chapter 11 and 12 that
I do have the book. I don't know if I have a solutions manual here. 11 and 12.
So what I'll do is I'll take pictures, whip something up, and email it to you.
Well, you can do that, or you can just tell me what number it is.
Oh, okay.
In the book.
So it's chapter 11,
Okay.
number 23 and 26. Okay, 23, that looks like it's a cyclopentene, is that right? 23.
Looks like this, and then there's hydrogens shown? 11.23?
Yes.
Okay.
Yep, with 3 hydrogens, and then it has the alkene, or
Yep.
I'm sorry, alkyne on the yes.
Yeah. Okay, so consider the different carbon to hydrogen bonds in cyclopentene and rank them in order of increasing bond strength. Okay. Now, the way to approach this question is to look at the different kinds of carbons that are in this compound. The compound is mirrored on the left side, so whatever you say about the right is true about the left. So this carbon is vinylic. This carbon is allylic. And this carbon is alkyl. Okay, those are just their names, like my house, my neighbor, my down the street neighbor sort of thing. Let me move that up a little bit. Okay, so when you analyze bond strength, what you really have to analyze is the stability of the thing you're trying to make. So for example, if you could take this in 3 directions. Okay. And you could lose a vinylic hydrogen, you could lose an allylic hydrogen, and then you could lose an alkyl hydrogen. Right? And so this is the radical chapter. So it's talking about making a vinylic radical, an allylic radical, or an alkyl radical. Okay. The only one of these that has a resonance structure is the allylic one. Okay, so allylic radicals are resonance stabilized.
Okay.
Okay. So since the allylic radical is resonance stabilized, it means the cost of the energy requirement to get here is low compared to the other 2. So this would be the lowest energy carbon to hydrogen bond because it's the easier product to make, and the product happens to be resonance stabilized. Neither of these 2, vinylic or alkyl, are resonance stabilized, but this one is a secondary radical and this one is a vinylic radical. Vinylic radicals are not stable at all. So this is going to be the highest. And that would just be something that you would have to know. Vinylic radicals are not stable. Vinylic carbanions are not stable. Vinylic carbocations are not stable. That means it's very hard to make them. And then the middle one, this would be in the middle. So you always have to rank. When you do a theoretical ranking like this, it all is going to depend on the energy of the thing you're trying to make. And then you always have to have a comparison. Like if it was just like, what is the energy associated with making an alkyl radical? You don't have any idea. Is that 100 kilojoules per mole? 1,000? That's not a appropriate question. What this question is sort of leading you to is that since that allylic position creates a radical that's resonance stabilized, in that allylic bromination reaction, you're going to end up with a bromine in the allylic position and not in a vinylic position and not in an alkyl position.
Okay.
So allylic bromination always puts a bromine on the allylic position because it's the easiest bond to break in the first step.
Okay. The book says that. But
Yeah.
it makes a lot more sense now. So.
Okay.
Okay. Thank you.
And the next one you said was which one?
What did I have here? I think it was 20. No, it was 31, 1131.
Okay.
I got a whole bunch of them. So if other students have questions, I'm not going to say.
No, this one, Yeah, this one I can go through pretty quickly. So this is the reaction that we just discussed. It's just not asking you first to analyze the bonds. It's assuming that now you know that you have to find an alkyl hydrogen to abstract. So this is the alkene that's shown, but I'm only going to show one of the 3 methyl groups on the side because you're going to get the same product no matter what you take, which proton you decide to take first. Okay, now before the reaction takes place here, the NBS in light reaction generates a bromine radical. So this has to happen like on the side. And it happens more than once. Okay? The first bromine radical is going to be responsible for pulling, oops, that's bad, pulling that proton or that hydrogen radical off and making a bond to HBr. So then from here you would get 2 products. The allylic radical and HBr. Now the HBr comes back into here. So the NBS cycle keeps the HBr concentration low so that you don't get a hydroboration reaction on any of your regular plain alkenes or alkene substrate. So this compound is resonance stabilized with this radical. NBS is going to kick out, continually be kicking out radicals. And you're going to end up with a product like this from one resonance structure and this. Okay, so the thing though to remember about resonance structures is it's not like when you get to this point, 50% of them look like this and 50% of them look like that. Okay, 100% of them, let's say, are going to have a pi bond delocalized here across those 3 carbons, and then there's going to be like a baby radical here and a baby radical here. The radical is going to be shared between 2 carbons and the pi or these 3 carbons, as are the pi bonds. So there's negative electron density here, which can be form a homolytic bond with the bromine, and there's negative electron density here, which can form a homolytic bond to the bromine. So both reactants or both products are possible. Because if something is resonance stabilized, it'll increase the type of products you make because of the various positions on the actual structure that will either carry a positive charge or carry a negative charge, carry a radical lone electron.
Okay.
Fair enough?
Yes. Thank you very much.
Yep, no problem. Oh, my washer's out of balance. Hold on a second. It's banging. Sorry about that. Okay. Next thing. Oh, shoot, Annie. That pi bond was between 1 and 6. So I had the ring like this. I'm just going to do it flat right now. So the chlorine and then a methyl. And so in this, if you named this, this would have been 1 chloro, 2 methyl cyclohexane. And the way I drew it in the ring, so these had to be trans to one another for this to work. Okay, trans. And the only carbon that had, the only beta carbon that had a anti-periplanar hydrogen was carbon 6. So then when we did the E2 elimination, the pi bond ended up here, and then the methyl group would be here. Okay, all right. Beyond like this example, what kind of stuff do you want to go over, Annie, with IUPAC naming? Like alkenes, alkynes, alkyl halides. Okay. Did it matter if it involved stereochemistry? I guess it doesn't really matter. Okay. Now this would be chiral, but I'm going to just keep it flat so we don't have to do R and S. And then if you want to do R and S on this, I can add stereochemistry. Okay, so the first thing you have to do, actually let me make this one longer. Okay, is you have to find the longest carbon chain. And not, because you have free rotation, this one, the longest chain is going to be kind of along this curve. And then you have to number it in both directions. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you have to go number in the opposite direction so you can decide the best choice of your locants. Okay, so the red pathway has substituents on 5 and 6. The blue pathway has substituents on 4 and 5. So this is the one that's the best numbering scheme. Okay. This would be a fluoro substituent. This is a methyl. Since M and F comes before M, so the fluorine group has to be named, put in the name before the methyl group. So this one would end up being 4-fluoro. Oops. 5-methyl nonane. If the stereochemistry had been indicated, then before this name, there would have been like a 4R, 5R, or it would have been 4S. But these numbers are the same as the numbers in the parent chain. But since I didn't draw the stereochemistry, that is a moot point. It's just you have to do it if the stereochemistry is shown. What do you mean by characteristic groups? Oh, no. It's there. Those are alphabetical. So you have a list of, you have some substituents. So you would have, if you had this, it would be a fluoro group. Fluoro, bromo, iodo. And then you have your chain alkanes. So here you could have a methyl group, an ethyl, then a propyl, etc. But once you get to here, you have various ways in which you can attach from the parent to the 3-carbon group. And these are all equivalently, I guess, of importance. So like if you had an ethyl group and an iodine group, the ethyl would be named before iodine. But if you had fluorine and methyl, then fluorine would be named before methyl. Okay. If this is your parent, and you come out to your substituent, and it's just, a propyl group, just a straight, it's coming onto a primary carbon and it's just a chain, then it's called propyl. Okay. If it comes off like this and attaches to the carbon in the middle, then it's called an isopropyl. Okay, and you use the I to alphabetize and the P to alphabetize. Let me move this so I can get, oh, I'm not sure I can. With the 4-carbon groups, it's a little bit trickier. 1, 2, 3, 4. Just don't 1, 2, 3, 4. This is a butyl group. Okay, now this is a sec-butyl group. Okay, and you alphabetize by the B because sec is referring to a number and numbers don't get put into alphabetizing. It's just like if you had dimethyl, you still alphabetize by the M in methyl and not the D in di. Then you have this one, which is isobutyl, alphabetized by the I, because I is not referring to a number. And then you have the chicken foot one, which is called a terse butyl. And the terse is referring to a number, so you alphabetize by the B. These are like, I'm sorry, I know it's ridiculous. We all just have to follow the rules. But yes, and then it is complicated to keep the things in order of what you have to use for alphabetizing, what you don't have to use for alphabetizing. But if the prefix involves a number, this stands for secondary, this stands for tertiary, then you can't use those to alphabetize. But ISO is not a number prefix. It's just part of the name, the worded name. Okay, with alkenes and alkynes, they go first in numbering, but not in naming. Well, in that case, the alkene gets higher priority. Okay. And the same would be true for an alkyne. So you have your chain, then you would number it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now, in this case, the way you pick your number is on the positions given to the pi bond. So it could either be a 2 or a 3, a 2 to 3, or a 4 to 5. Okay. 2 to 3 is lower numbers for the higher priority group. So it ends up that you have 6 chloro, 2 hexene. The other way to write that would be 2 chloro, hex, 2 ene. And then if it would have a triple bond, you would do the same thing. You'd make sure that the triple bond's origination carbon was as low of a number as possible. Okay. No. So the question is, what would happen if you had an alkene and an alkyne? We didn't go over that. It's possible. They're called ene-ines. Ene-ines. They contain both a double bond and a triple bond. But we didn't go into that as far as which would have the higher priority. I mean, I'm assuming the triple bond would have the higher priority, but we didn't really go over that. The only other time I think that it could be tricky is if you had a ring with a pi bond and a substituent. Okay. Because the pi bond has to have the higher priority. And so this would have to be carbon 1, carbon 2, carbon 3. Okay. If you went around this way, it would be still 1 and 2. But then your methyl group would end up on 6. And so 1 as origination for the pi bond and 3 for methyl is a lower set of numbers than 1 for the pi bond and 6 for the methyl. So this would be 3 methyl 1 cyclohexene. I would have done 1, then methyl on 2. Yeah. But in that case, Annie, you would have been going, oh, dang it, that's not the thing I want to do in the race. You would have been going around the ring. Okay. Yeah, I understand your point. 1, 2. But then if you say the pi bond starts on 1, it must end on 2. And the way you were numbering it would have been a pi bond between 1 and 6. You can't do that. It has to be like in numerical order. It would start on 1, go to 2. If it starts on 2, it has to end on 3. If it starts on 4, it has to end on 5.
Can I ask a naming question about this?
Of course.
So on the exam, the most recent exam, there was one that was kind of similar to this, and I can't pull it up right now, I don't think, because I think I have to be on the lockdown browser thing. But
Oh, okay, I can pull it up.
okay, there were 2 options, and I had originally picked the right one, of course, and then went back and changed it. And the one that I picked that was wrong, the reason I picked it, and now I think I know the like why it's wrong, but I wanted to check, is there was only 1 double bond in the ring, and I didn't know if there's only 1 double bond, are you required to put the 1 in front of the like hexene?
Only if there's other substituents.
I think there were.
Let me look. This one.
Yeah, this one.
Okay. Now watch me get it wrong. Okay. I would have started here. So 1, 2. So the pi bond has the lowest priorities. So this would put a pi bond starting on a carbon 1 as well as the first substituent on carbon 1. 3, 4, 5, 6. So that's a propyl, ethyl, methyl. Right here, you're asking why it's not listed as cyclohex-1-ene. Wait, okay, 4.
I think maybe I picked, I can't see what you're drawing right now, but I think
Oh, sorry, that makes sense.
Sorry.
Sorry. I would have put the 1 here and the 2 here so that the pi bond gets the lowest numbers possible, which would put a propyl group also on carbon 1. 3, I would have put 4. Now, if I'm wrong, then I'll have to figure that out. So 4 ethyl, 5 methyl, propyl I would have put cyclohex. I would have put a 1 there. But when you look at your options, I don't think there is an option where this 1 here is not given, and with alkenes, since alkenes have priority in a ring, well, in a structure over the substituents, it could just be that telling the reader that it's on carbon 1 could be redundant, because it is the highest priority carbon. So it would have to start on carbon 1. So I'd have to put it into a ChemDraw program to see the result of that. But it's probably a redundancy, because you have a pi bond in the ring. The pi bond has to be between 1 and 2. Okay, a single pi bond in a ring has to be 1 and 2, no matter where the substituents are. So this origination point written in the name could be redundant. Okay, but when you look at the options, down here, it's being shown, but the numbers are wrong, because the propyl is on the carbon 1 as well. So this is incorrect. This is incorrect, because the group on carbon 1 is a propyl group. This is incorrect. And you have the propyl here on 1. So based on, Dr. Barrios Sosa wrote this question. So my assumption, and I'll double check with the rules in the ChemDraw program, is that 1 marking the pi bond becomes redundant. So the placement of the substituents here is in this last option is correct.
Thanks. I have one more question about naming.
Sure.
If you have a chain,
Okay.
and there is a substituent, let's say, on either side, starting at the second carbon. That's the first substituent you see coming from either direction.
Okay, so let me draw something, then you tell me if I'm following what you're saying. So you have a chain, and you have a substituent here and a substituent here. Is that
Yes.
right?
Yes.
Okay.
Exactly.
What are the substituents?
Well, I guess my question is just in terms of alphabetizing. Is this when you...
Yeah, you'd use alphabetizing. So let's say you have a chlorine and a bromine.
Okay.
And so this would be carbon 2, and this would be carbon 2. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be 2, 9 versus 2, 9. Well, you can't distinguish between them. So then you use the alphabet. And since B comes before C, this would be 2 bromo, 9 chloro, decane.
And if there was another one, let's say on 4, you would...
Then you would have a distinction point. I'm guessing. So let's see, 1, 2, 3, 4. Let's put a methyl. So 1, 2, 3, 4. So that would be 2, 4, 9 versus 2, 3, 4, 5, 6, 7, 2, 7, 9. So then now you have a clear break in the numbering that differentiates one path versus the other.
So then the alphabet wouldn't matter in terms of numbering.
Not in terms of numbering, but then you would go back to the alphabet when you list them. So
The right order.
yes, so it would be 2-bromo, 9-chloro, 4-methyl decene.
Okay, perfect. Thanks.
Yeah. Oh, I don't know what I just did. Okay. I tried to clean my mouse off. It didn't work. What do you guys see right now? My screen? My whiteboard?
Yeah. With
Okay.
the picture of your mouse, actually. I think that's your mouse.
It's a like a teal sort of thing.
I see a big white arrow in the bottom right corner of my screen.
Oh no, I think I froze something. Oh gosh. Let's see, resume share. There we go. Here we go. All right. Now do you see like my hand?
Yeah.
Okay, perfect. Okay. All right. Okay. Any other questions? Does anybody have any acid-base questions? Okay, I might have to just meet her one-on-one then.
I have one more test question.
Sure.
On the first test with, it was the molecular orbital theory.
Mm-hmm.
I was trying to count the electrons, but every single option I couldn't figure out, like none of them matched up with the number of electrons I was counting.
Okay, let me see. On exam 1. Yeah.
Yeah.
Probably the last thing I had to get to.
Sorry, I tried to pull it up on
No,
mine.
it's okay. It's just they scramble them every time you go in. And so they're never where you think they are. So you have to look through all of them. Okay. All right. Now we're, okay, here. Yes?
Yes.
Okay. So let me see if I can annotate this. Yeah. All right. So the resonance structure for this, I think it's harder because the lone pair is not shown. So for that carbon to be a carbanion, it has to have 2 extra electrons on it. So that is the resonance structure, but then what's not shown are those 2 lone pairs. So there's 2 electrons here, and there's 2 electrons in the pi bond. So you have 3 atoms stabilizing 4 electrons. And then my drawing's gonna just have to come with me. Okay. 3 molecular orbitals stabilizing 4 electrons right here.
Okay, yeah, I definitely didn't think about the lone pair.
Yeah, so remember you have 3 different ways you can have carbons. And remember, and that's an unfortunate part of line bond drawings. You don't have to show lone pairs. So this is a carbanion. But it's, like I said, the lone pairs aren't shown. Then you would have, I'm just going to draw it flat. Then you would just have your regular plain old carbon right here in the middle. Here, that would be neutral. So this is a carbanion has a formal charge -1. This is just a regular carbon, formal charge of 0. And then you would have the carbocation formal charge +1. So all compounds or all atoms can do this. Like you have a regular oxygen, 2 bonds, 2 lone pairs that has a formal charge of 0. Then you have oxygen anion, which would have 1 bond and 3 lone pairs, formal charge -1. And then an oxygen cation, 3 bonds, 1 lone pair, formal charge +1. So all the atoms can do this, but the only ones that have specific names are carbon. Formal charges that are higher or lower than -1 and +1, those are really rare to find, because having an atom with a formal charge, whether it's a positive or a negative, is not the atom's most stable bonding situation. And so the farther you deviate from the structure that would result in a formal charge of 0, the less stable that structure is. So the carbocation is highly reactive, the carbanion is highly reactive. But if you would get like a carbocation with a 2+, that would be even more reactive than a carbocation with a 1+. And so when you do formal charge analysis, it's pretty rare to see them greater than +1 or less than -1. Yes, Annie, I'll go over, well, hopefully it'll be 3 on this exam when we go back. Okay, are there any other questions about this, any of the ideas taught? So there's a resonance, there's a molecular orbital theory, and then there's lone pairs not shown. Okay. Hopefully I can. Okay, is it this one that you had a question about, Annie? Okay. Oh my gosh. Compound shown below is responsible for giving cinnamon its color and flavor. The correct hybridization. Okay, so this carbon. Oh, I'm gonna sneeze. Excuse me. The carbon in that aldehyde group is sp2 hybridized. Okay. So sp2 hybridized means that you're going to have a 1s orbital left alone, because those are core electrons. The 2s and 2 of the 2p orbitals were used to make the hybrids, and the remaining 1sp orbital is unhybridized. Okay. So so you're told in here the lowest energy is 1s. So you have 1s, 2s, and then the 3 p orbitals. So this is just unhybridized. This is just the atomic ground state for a carbon atom in the gas phase, not making any bonds. Okay, so 1s, and then here's 3 sp2s, and then a higher energy orbital. So this one's looking pretty good so far. Let's just check again. Okay, this is wrong because it's a carbon atom, which can only have 6 electrons. 1, 2, 3, 4, 5, 6, 7. So this has too many electrons. 1, 2, 3, 4, 5, 6, 7. Too many electrons. So it has to be this one. So even though, like, the energy difference shown here, I keep forgetting you can't see my mouse. The energy difference shown here is shown actually pretty big, and it's actually small. So the promotion of this electron is a lower energy process than partnering to pay the spin pair energy. So, I mean, there's a couple ways to go about this problem. The first is to count the number of electrons, because at least these bottom two have way too many electrons for a carbon atom. And then the difference from what's shown here and what's shown here is that this is just atomic carbon, and this is carbon making bonds. Anything else for today? Okay, if there isn't anything else today, then we will end for today. You are welcome to attend any of the review sessions between now and tomorrow night, either mine or Dr. Barrios Sosa's. And I'm assuming she'll do the same as I'm doing, is recording them and putting them up. So don't feel like you can't go, and reach out if you need something. I'll do my best to explain things by email as well. So just let me know what y'all need.
Thank you.
Yep, you're welcome. I'll see you all tomorrow night at 7:30. Oh, sure. Yeah. Okay. So I will see y'all tomorrow night then.
Dr. Walters?
Yeah.
Oh, I just had a quick question. This is regarding OR2.
The what?
This is regarding organic 2.
Oh, yeah. Sorry.
No, you're fine. So would be the expected, like, workload and stuff like that? Would it be the same?
Are you taking it in summer 2?
So, well, I'm not enrolled in it,
Okay.
but I guess my question is, like, I would like to eventually take biochem. I actually need to.
Okay.
So how much would OR2 pay off for that?
Well, do you have to take the chemistry There's 2 different biochemistry courses on UNCW campus. There's the chemistry biochemistry and biobiochemistry. They're taught totally different.
Okay.
And I always forget, like, if you were a chem major, you can't substitute the biology biochem.
Mm.
And I think if you're a biology major, you can't substitute the other way around. Or maybe maybe even bio you can. Organic 2 is a semester of that, like, if you break up our semester, the way I view it is chapters 1 through 5, which are just the molecules, naming them, conformations, they're not actually doing any reactions. That seems tricky until you see what's in the second part, which is all the reactions and the transformations.
Okay.
That's my opinion. The reactions can feel overwhelming very quickly. And I say this as, having taken the class as a student myself. All of a sudden, organic can feel like you're going to get hit by a bus at any second. Organic 2 is all reactions.
Okay.
From start to finish. And unlike Orgo 1, where we have a sort of a soft start with a general chemistry review, there isn't an Orgo 1 review at the start of Orgo 2. It's just, let's get going. And things like, do you remember your pKa's? That has to carry over. Your reactions from this semester have to carry over. In terms of the workload, I don't know what Dr. Barrios Sosa is going to do this summer. I don't know if she's going to continue with Alex or modify Alex or not involve Alex at all. Like, you guys were kind of our trial run with Alex, thinking that we were going to be face to face. Obviously, that we ended up online.
Well, Alex to me is not a determining factor. It's
more.
It's
okay.
homework.
Well, I mean, it would be if you had to pay for it.
Oh
like,
yeah.
I mean, then you'd be like, well, I don't want to put the money into that thing.
Mm-hmm.
I didn't like it, and but you would have to ask her, and I haven't actually talked to her about that. In terms of biochemistry, it depends on what you want to do. If you have a choice, I don't know this. I don't know the biochemistry class. I just know I know the instructors for the chem biochem course, and I think, and it's Chem 365. I think it's a tough course from what I've heard from students.
Mm-hmm.
If you take chem biochem, you have to take Orgo 2. I don't know the requirement for biochem.
I think so. I would take the biology, biochem.
Mm-hmm.
And I don't think that I'm almost certain that Orgo 2 is not a requirement.
Okay.
But kind of going along the lines with what you're saying is that, like, I need to retain whatever.
Mm-hmm.
And
if you are planning to take the MCAT, like, I don't know what anybody's plans are. Like, you can go to medical school majoring in anything you want. Yeah. You can be my best friend's husband is a doctor, and he has a major in like physical education.
Yeah.
But then you take the prereqs and you take the MCAT, you go in. But I am pretty certain that the prereqs for medical school involves both Orgo 1 and Orgo 2. PA schools, I think there's some in the area like Campbell, I think only requires you to take 101 and 211. It doesn't even require 102.
Yeah. Right now I'm looking toward the PA route, but just kind of based on, I think we had talked about this before, the amount of knowledge that went out of my head between Chem 2 and here was literally within weeks. And if I were to try to go back to org in really, let's just say either in the fall or in the spring, like it's lights out for me. So
I would not. If you don't want to take it in the summer, the latest I would push it is fall.
Yeah. Okay.
Orgo 2, honestly.
So who would I? So I know I went on CNET yesterday, and I need to make a decision. But who do I need to? Because right now it's overbooked. It looks like it's overbooked.
Dr. Barrios Sosa could give you an override into the class, but it's likely that you can't get an override into the lab.
Okay. I did talk to Professor Corpus yesterday about that, and specifically she said she wouldn't have an issue with it.
Oh, that's good. That's good.
Because they're playing around with the numbers. There's a whole admin side to it that
Oh, yeah, yeah.
Anyway,
And I haven't talked to her about Orgo 2 labs just because we're also moving out of those trailers that we had been in into permanent buildings. So I know her numbers are a little bit based on just the logistics of what she has to do when she's not teaching.
Mm-hmm.
The problem with the summer 211 is you don't get a lot of days to kind of test the waters before drop ad without it being on your transcript. Like for us, I think we started on a Wednesday and I think drop ad was Friday.
Mm-hmm.
And you're like still a week away from your first exam. So you don't even really know how you don't have any way to tell where you are before drop ad. And that would be true in summer too as well.
Yeah.
But
no, that's fine. I was just you know, getting your thoughts on it. And I mean, ultimately I just have to kind of,
a lot of it does depend though on what you want to do. Like if you want to go to PA school and you don't have to take Orgo 2, don't.
Yeah.
And then take.
I was thinking that, you know, you're absolutely on point.
And then take biochem.
Yeah.
You know, I mean, and it's not that I don't think you can do it. I just think like you have to think about the cost benefit, or, you know, the benefit cost analysis, like not in terms of money, but in terms of your time and the effort it's going to take to get through Orgo 2, especially in this online platform. And it's not to disaway. I mean, there's other people listening in on this conversation.
No, that's fine.
You know, and if your plan is to go to medical school, I'm not trying to talk anybody out of anything. I'm just trying to sort of, you know, give you, like, you don't want to be miserable. Like, I started as a bio major and I hated biology. I mean, I hated it.
Yeah.
So at the point where I was like, I cannot do this anymore. You know, there's no point in keeping on going to do something that you don't enjoy doing. Like, you want to be in, you know, you're going to have to take classes that are like, this is not my favorite. But in general, you want to enjoy your experience, I think. Mm-hmm. So I would look at what you want to do, and if it is PA school, I would do a Google search today for a couple hours. And if you're clearly in North Carolina and local to Wilmington, I would look at, you know, the PA schools, and I'm not being judgy or whatever. There's medical MD schools, and then there's DO schools. DO is becoming like a huge thing, and they may have different requirements. And so you may want to look at, you know, is Campbell the only PA school that doesn't require Orgo 2? And if that's the case, then you should take it, because you don't want to have to take it later. Yeah,
that's the thing. So all of the schools that I'm looking, I have a list of 8 schools that I'm PA schools. None of them require Org 2. 1 or 2 require biochem. But
and if it doesn't specify, and are you a bio major? Yeah. Then take biochem.
But like it may sound silly, but one of the reasons why I like chemistry is just because I'm not really good at it. It's a pretty good challenge.
Yeah.
But it's pretty miserable at the same time. But with Org 2, this is a very small window. So like, in order for me to try to get back into an Org 2, I'm going to have to retake, you know, I would have to go back to a community college, go back, if I were to say do this in a year or something like that, like either that or just, that would be it would just be really rough. So the biggest determining factor is that it's a very small window of opportunity to take this, even though I may not need it. It'll give me a lot more options for taking higher level classes if I choose to, and then, right now it's PA school, but if I choose to go the MD route or the DO route, that's out of the way. Then all I have to do is refresh, but at least I have. Right,
then studying for the MCAT. And the other thing to remember is it's hard, I think, when you're in the student mode looking towards a professional school. You know, there's so much more to what goes into an application than a GPA or a grade in a certain class. Or, I mean, I know that there's a lot of pressure on people who want to go into the medical field, because sometimes the first screening is just that MCAT score. And so then they don't see your, your breadth of experience without an MCAT score. But there's always more, that goes into coming into. I've had students in organic classes in the past ask me what my grades were in organic as an undergraduate. And I'm like, I'm pretty sure I got, B's.
Mm-hmm.
And, I flat out failed physics too. I mean, it was a horrible experience, but I still feel like I ended up, I'm an okay person, even though I have, some rough semesters and had some bad scores. So, there's more that goes into who you are when you put yourself forward for application into schools.
Oh, no, I mean, I absolutely. Flying through in straight A's, I mean, there's nothing certainly wrong with it. They put a lot of work into it, but there's not a few bad marks. Are they really challenging themselves? I think they take that into consideration too. So okay. The with regards to the ALEC completion, once we hit that one, I don't know if I thought I'd sent you an email. I don't know.
You did.
So the PI says 100%, but then it wants me to go back to review. I'll do it.
Yeah, I mean, like I said yesterday, I mean, we haven't exactly talked about how we're going to assign a final grade, although no matter what you get, it's not going to be lower than what you have on there. In any case, most cases, it's going to end up higher. I mean, most things we do in the class are curved, and it's not supposed to be a negative. It's supposed to have been, the intention was for it to enhance the experience and help throughout the class. If it didn't help, I need to know. But I mean, because you guys are online, the comparisons in exam scores, I can't do that. I can't compare your exam scores to an in-person class exam scores, because the entire class is different. I've never been this far ahead of a calendar as I have been since teaching online, because I can't see your body language. I can't see the face, like everybody's faces of like, you're going too fast. I just keep going unless somebody says something, so it's just a different learning experience. But I don't know the ins and outs of the ALEX program. So I don't know if it's going to stop you. Like if it says 100, but then in the grade book it says 97, I don't really know. I don't know what to tell you, I guess.
I'll go back in there, and the thing is, we keep getting kicked back because there's this mystery score that, one, we don't really know what it is, and two, it just says a score. We don't get to look at what we got wrong. It just makes us redo the modules.
Oh.
So that's kind of I wrote a pretty blistering discussion board on it.
Okay.
It's not all bad. Most of the stuff is I think a quick fix. But anyways, I'll go back in there and play around with it. But I was done at one time.
Okay.
So
I mean, to be completely honest with you, I am not a huge, you guys used MyLab and Mastering in general chemistry.
Yeah.
And in general chemistry, I added in those dynamic study modules, and people seem to like the dynamic study modules better than the static homework, because they ended up being tailored more towards the student needs.
Yeah.
Which is why I thought to try ALEX in organic, because it's also adaptive learning, individual for each student. Yeah. But it may not be appropriate for an organic class. It may be more appropriate for a general chemistry course. And I just need to know, the thoughts from the students of, I liked it, but I would have rather used it in place of Pearson and Gen Chem and focused on the textbook stuff in organic.
Yeah.
Yeah, that's kind of stuff. So.
Okay. All right.
Oh gosh, 50 topics. Ugh. Just do the best you can, and it'll be. I promise that I will do everything I can numerically to make sure that nobody is screwed by ALEX. So now I'm going to be on the internet forever having said that word in a class.
Okay.
In real life, who knows what I say, but on recorded life, I try to keep it clean.
Thank technology for that.
Yeah.
So, okay. Thank you very much.
Yeah, no problem. No problem.
Dr. Walters, I had
Yeah.
one question.
Sure, Thomas.
I already talked to Dr. Almeida about it, but hopefully you might be able to answer it. I asked her if she knew any of the pre-med advisors at UNCW. Like, I did a little bit of fishing. I emailed someone, but they never replied back.
There used to be a guy in biology that pretty much everybody would go through, but I think he retired. So, are you a bio major?
I'm actually a psychology major.
Psych major.
So, funny, har. I used to be a biology major, but I'm doing the same thing as you. I did not like how
I hated biology. Oh my God. I didn't mind the first semester so much, but the second semester was like, it was horrible.
I don't understand how the biodiversity has anything to do with medical school.
Yeah, well, neither does PChem, but some people major in chemistry. So I would email Melanie Canfield.
Okay.
And then there's it's a woman, her name is Ryan, spelled R-Y-A-N, but I can't remember her last name. But they are the undergraduate advisors for biology majors. And most of the UNCW students most of them that are trying to go to medical, or, plan to apply to medical school do come out of the biology department. And
Right.
it's true in all universities. So I would check with them. There's pretty standard courses that you need for prereqs, like you need anatomy and physiology, the orgo classes, the bio classes. So they would know. I know for my department, you need through orgo too for most medical schools. PA schools are different.
Yep.
And I don't know enough. The DO thing is coming up fast for me. Like, that is a new thing that all of a sudden people are like, well, I'm applying to DO school. So my assumption is that it is the same as the prereqs for MD, but I don't know.
I need someone to talk to, because I've gotten all A's and B's in my classes. So God forbid, hopefully in this class.
Yeah.
But
I would try Melanie Canfield.
Okay. Because I know organic is one of the most important requisites, because it's geared on how well you're going to do in medical school.
Yeah, they use it as a bottleneck, really.
Because most people are going to get A's in the general classes.
Yeah.
Okay. One other question. I did ask Dr. Almeida about it, but I am doing a minor in chemistry and biology. She had recommend medicine. I can't say it. The medicinal chemistry.
Oh, medicinal chem?
Thank you. Yeah, medicinal chem and environmental chemistry. Would you recommend any of the other classes for a minor?
Medicinal I think would be very helpful, because it's especially coming right out of organic.
Right.
Then I think that would be a nice transition point. Some students take it's 312, which is advanced. I've taught it before and I can't remember the name of it. Advanced techniques in organic chemistry. So it builds off organic chemistry, but it takes you into a little bit more depth of like the instrumentation, which isn't really what you need for medical school, but it's a nice continuation out of orgo, a little bit smooth. But environmental is a great class, and every now and then there's a forensic chemistry class offered. You could take anything. You could take chemical oceanography. It's just not going to help you with medical school. The medicinal would probably be one of the better ones to take with what you want to do.
Okay. I just wanted to get another chemistry teacher.
Yeah. And Dr. Varadarjan is the one who typically teaches medicinal, and he is amazing.
Okay.
amazing. Like when I need and want like a refresh of Orgo 2, I sit in on his classes. He's just incredible. He's so good.
Okay. All right. Thank you so much.
Yeah, you're welcome, Thomas. Have a good rest of your day.
Yeah.
Okay, bye-bye.